Today we're going to be solving quadratic equations by finding the square roots. And if you guys notice on the left hand side, I have listed the square roots, the perfect square. So square root of 9 will be 3, all the way down to square root of 144 is 12. Now we're going to start by simplifying using two different properties of square roots to be able to simplify. And this comes back to the properties of exponents. The first one is when we're trying to find the square root of 50, there are two ways that we're going to be simplifying this. One way is to be able to do what we call the factor tree. And many of you guys are used to doing this. So the factors of 50 will be 10 times 5. The factors of 10 will be 2 times 5. The factors of 5 are just 5 and 1. I don't need 1 because that'll give me the same thing. I just need the prime numbers, and 1 is not a prime number. Now, I'm going to place them all inside the square root. So 2 times 5 times 5. And because this is a square root, I'm going to take out the pairs. So I'm going to circle the pairs. 5 times 5 is 25, and the square root of 25 is 5. Notice every time I have pairs or twins, I take them out only as one of them. There are two 5 insides, I only take them out as one. But the properties of the product property will tell me that if I can separate this 50 as a factor, and I will be using the factors on the left hand side. So I know that 25 is a factor because the square root of 25 times the square root of 2 is the square root of 50. Then from here, the square root of 25 will be 5, and then we just bring down the 2. So notice that we get the same answer. Most of the time, I want to try to do this because it's going to be much faster. If the number is big, then I'm going to go through the whole process and just find the prime factors and take out the pairs, and that'll give me exactly the same answer. Now the quotient property. The quotient property tells me that if I have a square root, I can separate if there are two numbers divided. So I can separate the square root of 49 over the square root of 25. From there I can simplify. So the square root of 49 will be 7. The square root of 25 will be 5. And that'll be my final answer. So we're going to be using those properties to simplify the following expressions. And then we're going to be using the same properties to be able to solve or simplify the solution once we solve an equation. So let's try example 1. You can do it two ways. So if you want, you can go and try doing the factor tree. Another way is being able to find a number, the biggest number that divides 48 out of the perfect squares. So I know that I can divide by 16. So that gives me the square root of 16 times 3, because 6 times 3 is 48. Now, square root of 16 will give me 4, and then I have the square root of 3. If you want to be able to simplify the other way, you can do the same process. The square root of 48 will be, I'm going to do the factor tree. So this will be 2 times 24. 2 is a prime number, so I'm going to bring it all the way down. 24 will be 12 times 2, or 8 times 3. This is a prime number. This will be 4 times 3, and then this will be 2 times 2. So all the prime numbers will be written inside the square root. I'm going to place them in order, so 1, 2, 3, 4 2's. And then I have 1, 3. I'm going to go and take out my pairs. If you notice, I have a pair of 2's here, a pair of 2's here. So 2 of those 2's come out, and I have a 3 inside. So 2 times 2 will be 4, a square root of 3. Notice I get exactly the same answer. So it's up to you. If you want to do the short way, by being able to find the factors of 48, but it has to be from this list, so we can take the square root. Or if you can't think of them, you can just go through the prime factorization and take out the pairs. Let's continue with example B. On example B, we have a 5 outside, so we just need to be able to find the factors of 60. You can do it this way, so you can find the factors of 60, or you can just do the factor tree. In this way, I can't think of anything that divides 60, so I'm just going to do 6 times 10. The 10 will be 3 times 2, or 2 times 3. This will be 2 times 5. I'm going to place them all inside. Now notice that the 5 is still outside. Inside, we have a 2, 2, 3, and 5. 2 times 2 times 3 times 5. I'm going to take out the pairs. So I'm going to take out the 2, comes outside. Inside, well, I still have my 5 outside, so let's not forget about the 5. We have a 3 times a 5. Outside, we have 2 times 5. I'm going to multiply 10. Inside, I'm going to multiply what's left inside, so 3 times 5 will be 15. So it's a simple process. Now notice that on example C, it's multiplying. So I'm going to go through the same process. I'm going to go and find the factors of 30, the factors of 6, and then I'm going to go and place them all inside one square root. So the factors of 6 will be 2 times 3. The factors of 30 will be 5 times 6. Factors of 6 will be 2 times 3. Now that they're all factors, I'm going to go ahead and write them all inside. So outside, I have a 2 times a 5. Inside, I'm going to place them all inside. Now notice that I place them both of them outside, and they both are multiplying. So I'm going to place them all inside. I'm going to place them in order, so I have 2 2's, 2 3's, and 1 5. I'm going to go and take out the pairs, so the 2's go outside, the 3's go outside. So outside, I have the 2 times a 5, times another 2 that I took out, times another 3. Inside, I have a 5. And now I just multiply everything that's outside, so we have, this will give us 10, this will give us 6, so it'll be 60, and a 5 inside. Now on example number 2, we are going to simplify the expressions by using the second property. Every time we have a square root inside this, we have a fraction inside the square root, we can separate it, so this will be square root of 7 over the square root of 3. Now we cannot have a radical or a square root on the denominator. So what we're going to do, we're going to rationalize it. We basically are going to get rid of the denominator, the square root on the denominator, by multiplying by the square root of 3. Since this is square root of 3, we're going to multiply the top and the bottom by square root of 3. Then we're going to simplify, so square root of 7 times square root of 3 will be square root of 21. Square root of 3 times square root of 3 will be square root of 9. Now we know that the square root of 9 is equal to 3. And that will simplify it. So let's try letter B. We're first going to separate the fraction into two different square roots. We want to be able to rationalize it. We want to be able to get rid of the square root on the denominator. So we're going to multiply by the square root of 5. And what we do on the bottom, we need to do on the top. So that will give us, now instead of multiplying, I know the square root of 4 is 2. So I'm going to simplify 2 square root of 5. If you want, you can multiply square root of 4 times square root of 5 will be square root of 20. And then once you simplify, you end up with the same thing. On the denominator, square root of 5 times square root of 5 will be square root of 25. So it'll be 2 square root of 5 over 5. Now be careful. Some of you guys are tempted to simplify or cancel those 5s. You can't, because this one is under the square root. Now try letter C. So for letter C, we are going to separate it. Same process. Square root of 2 over square root of 7. I'm going to rationalize it by multiplying by the denominator on the top and on the bottom. That will give me 2 times 7 will be square root of 14. Square root of 7 times square root of 7 will be square root of 49. I know the square root of 49 is equal to 7. So it'll be square root of 14 over 7. Be careful, you cannot simplify this. And that's it for example number 2. Now on example number 3, we're going to solve quadratic equations, and we're going to solve them by taking the square root. So very similar process that we have solved equation on the first chapter. We're going to draw the line, and we want to be able to leave the x by itself. Now if you notice, we have x squared. So before we can actually get rid of the square, we want to be able to isolate or leave this by itself. We're going to leave the x squared by itself, so I'm going to move the 5 to the right. That's going to become a negative 5. We have 2x squared is equal to 36. And then we can divide by 2 on both sides to leave the x squared by itself. So the 2's cancel. We have x squared is equal to 18. And we can take the square root of 18 to get rid of the square. So to get rid of the square, we're going to take the square root on both sides. The square root and the square cancel. So we have x is equal to the square root of 18. The square root of 18 is the same thing of the square root of 9 times the square root of 2. So square root of 9 will be 3, and then the square root of 2. Now every time that we take the square root, we need to have 2 answers. One positive and one negative. So every time you take the square root on both sides, we're going to have 2 answers. One positive and one negative. And this will be your answer. So x is equal to positive 3 square root of 2 or negative 3 square root of 2. But we can just leave it as plus or minus 3 square root of 2. Now in example number 2, or letter B, we're going to go through the same process. Remember that before we can get rid of the square, we want to be able to leave this by itself. Many of you guys are tempted to multiply the 2 times the x and the 2 times the negative 3. We can't. So we're going to get rid of the 2. We're going to divide by 2 on both sides. The 2 gets cancelled. We have x minus 3 squared is equal to 4. And now I can get rid of the square. Take the square root on both sides. The square root and the square cancels. So we have x minus 3 is equal to, the square root of 4 is 2. But remember, since I took the square root on both sides, that'll be plus or minus square root of 2. I need to leave the x by itself, so I'm going to move the 3 to the right. And when I move it, I want to be able to move it to the very beginning. So before the plus or minus. X is equal to positive 3 plus or minus 2. Now from here, I'm going to have 2 answers. One positive and one negative. So it'll be 3 plus 2 and 3 minus 2. So one positive and one negative. That will give me 3 plus 2 will give me 5. So that's one of my solutions. 3 minus 2 will give me 1, and that's the other solution. Notice that in here, because I have a square root, I did not go through the same process. Only when the square root is a whole number, then I can go through the process and separate into 2 different values. Let's go and try letter C, letter D. See if you guys can do it by yourselves, and then we can go through the process.